Okay, our next topic is negative exponents. And to prepare to understand what a negative exponent means, I'm going to ask you to grab your calculator and complete this little table with me. It'll also give you practice using your exponent key. Now remember, your exponent key is either an upside down V or y to the x. In some cases it might be x to the y. You should have one of those keys on your calculator. Again, if you can't find your exponent key, please ask me in class. So let's raise 2 to the 4th power in our calculator. 2 power up to 4, and as the answer shows, you should be getting 16. 2 power up to 3, you should be getting 8, and so on and so forth. 2 squared you can do in your head. 2 times 2 is 4. Now 2 to the 1st power, let's look at this pattern here. 16 and 8 how are they related? Well, 8 is half of 16, so we're getting twice as small each time. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So it makes sense that as these powers are getting one lower, these guys are getting half as big. So 2 to the 1st power, check it on your calculator, 2 power up to 1 is just 2. In fact, any number raised to the 1st power is just itself. And let's try your favorite number. Mine is 7. If I do 7 raised to the 1st power, I get 7. Now, if your favorite number was a negative number, we'd have to be careful and put it in parentheses first. So if let's say my favorite number was negative 5. I'd put in my left parenthesis, which is right here, the negative sign, then 5, close my parentheses, because I want to raise the negative and the 5 to the 1st power. And, whoops, I didn't power up. Let me go back, delete that, power up to 1, and I should get negative 5. So we're going to add a note to our paper. Would you add this note down here? This is very important. When a number or variable has no exponent, we assume the exponent is 1. Take a minute to write that out. Alright, and we have one example over here. 2 to the 1st power is the same as just plain 2. 5 to the 1st power is the same as 5. Let's write that one down. Let's put another negative number. Let's do negative 2 to the 1st power. That equals negative 2. Let's do a variable. X to the 1st power is just x. Okay, so keep those in mind. Alright, let's continue our pattern now. So if we're getting half as big each time, what would you guess 2 to the 0 power should be? What's the pattern? Remember, it was 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is... Did you guess the answer would be 1? Let's check that in our calculator. 2 power up to 0. It's 1. And in fact, let's read this. Anything to the power of 0 is equal to 1. Now there is an exception, and let's write it down. Except 0 to the 0 power. And we're going to find out that gives you an error in your calculator, so we're going to write it's undefined. That's what this symbol means. We can't do 0 to the 0 power. That's the only number that doesn't work. When you raise it to the 0 power, it will not give you 1. So let's think about this for a minute. Anything raised to the power of 0 is equal to 1, except for this one. Write your exception down. And let's kind of prove it to ourselves with our calculator. Alright, so 2 to the 0 power, we already proved ourselves. That's 1. Take your favorite number, raise it to the 0 power. Again, mine is 7. Power up to 0. I get 1. My husband's favorite number is 57. 57, power up to 0, is 1. 2 million powered up to 0 is 1. And a negative number, you got to put it in parentheses though, negative 10 for instance, to the 0 power is 1. But, as I mentioned earlier, 0, power up to 0, we have no definition for that. Your calculator will tell you error. So again, that's the only exception. So, what about a to the 0 power? As long as a is not 0, we can assume that variable raised to the 0 power is 1. Make sense? So variables, numbers, anything raised to the 0 power is 1. Alright, let's keep going in our pattern here. So if these guys are each getting half as big, if I did 4 divided by 2 to get 2, and 2 divided by 2 to get 1, what would you guess 2 to the negative 1 is if we're continuing to go 1 power lower? Well, it should be 1 divided by 2. Well, 1 divided by 2, can't we write it like that? Again, these guys are half as much as the one before. Half as much, half as much, half as much. And 2 to the negative 2 is 1 what? What's half of a half? It's 1/4. Now, there's another way to look at this pattern. 2 to the negative 1 is this one flipped upside down. It's 2 to the positive 1 flipped upside down. 2 over 1, 1 over 2. 2 to the negative 2 power is this one, 4, flipped upside down. And if we did 2 to the negative 3 power, it's going to be 2 to the positive 3 power flipped upside down. It's going to be 1/8. So, we have a property called negative exponents. If I have a number raised to a negative power, it's the same as 1 over that number raised to the positive power. Let's write out a couple of examples. For instance, 2 to the negative 3 power, that's the same as 1 over 2 to the 3rd power. And 1 over 2 to the 3rd power is 1/8. 2 times 2 times 2. So when you see a negative exponent, I call it the move it and lose it property. You think of this as a fraction, and if the base with the negative exponent is on top of the fraction, it has to move to the bottom to become positive. Likewise, if you come across a power, a base with a negative exponent on the bottom of a fraction, for us to make it a positive exponent so we can understand it, it needs to move upstairs. So this would become 2 to the positive 3 power over 1, or just 8. We're going to do some mixed practice on this to help you understand it better. It's a little confusing, I know. But let's take a peek at some examples in the next video.